So, good morning once again. We are back to our distillation process, and now I'm taking you to the distillation process. Here is our simple buffer tank for holding the beer, or a holding tank. And now here we are heading to our distillation section. As we can see, this is the clarifier. Then from there, the fermented wash flows through this buffer tank. Then from there, it is pumped up to the beer heaters. Then it flows down to our main preheating system for further preheating to our tubular heat exchanger. Then from here, it is transferred to a degasifying tower. Then from the gasifier, it flows down to our wash holding tank, of which I will show you here. This is our wash holding tank. Then from here, we transfer this material to our stripping or analyzer tower, and you can see the boiling taking place. And you can see our boiling points here for analyzer and rectifier, middle temperatures, top temperatures for both analyzer and rectifier. And from here, we take the material. The vapors will flow to the rectifying tower. The vapors flow to the rectifying tower. As you can see, the whole system. And we are right now in process. Our team is right now in process. So I'm taking you to where we tap off our Fusel oils. So this is where we tap off our Fusel oils. As you can see, we have our rotameters, 2 of them. And we'll make sure that it's pretty hot. We are tapping off the Fusel oils. Then after, we take them to pipe in, pipe out cooler, which we normally use, or you can use a plate heat exchanger. And from there, we take it to the decanter where I'm going to take you. And these are our vapors from the analyzer flowing to the rectifier cum exhaust tower. I think you can be able to view the boiling. Yes. So from here, our Fusel oils, both HF4 and LF4, are flowing to those coolers. They're known as pipe in, pipe out coolers. And from there, the liquid flows to what is known as a decantation system. Here we push in water and push on all the Fusel oils. Then you see that small thing, the pipe in between there. That one is called a bombardment area, whereby we mix and push in water at pressure so that we bombard and separate the Fusel oils away from the alcohol. So this is our next stage where we have our flow meter. From here is where we regulate our fermented mash flow. And here is our rotameter for the draw of rectified spirit. And here, that one you see there is known as a safe and tester. For us, we keep checking the strength of the spirit and the quality. Either if it's not good, you recycle it back, and if it passes the test, you transfer to the intermediate storage tanks. So you're seeing these are our TA takeoff lines, and those are for HF4. And the ones you see up there on the next trays are for LF4. On top of our vapor flows to the rectifying tower, since this one is using analyzer, because we don't have the aldehyde tower, we are using vapors flowing to we're having vapors flowing to the rectifying tower, come exhaust. So we're fixing this. This is known as a demistifier, vapor separator. So the vapors, in order to reduce on entrainment further up to 98%, you introduce this one so that when it creates a whirlpool in this vessel, the demistifier, only the vapors will flow to the rectifier, and the liquid, because it is heavier than the vapor, lose momentum and flows down back, and we return it back to the analyzer tower. Yes. And this is the condenser for the degasser tower, locally made by my team. That is cooling water from both the vent and the main condenser. That is cooling water return from both the main and vent condensers, so that it returns back to the cooling tower. Here we have some of these pots. You can see them. All of them are above the rectifier tower. Here, all these reflux pots receive what we'd call the condensate, alcohol condensate, which is flowing back to the rectifier for us to have a reflux, so as to maintain 96% of alcohol. As you can see right now, you can see the boiling. We have both manual temperature gauge and the RTD indicators of RTDs for monitoring. And here is where we are tapping the alcohol from, on top here, and the second one, but the third one is closed for purposes of not dropping the strength of our spirit easily. And in most cases, this is not the best where you have got to tap your alcohol from, because you need to maintain a reflux of all those low boiling impurities to keep recycling around, so that you have a good quality of spirit. But now, because we have attained, because we left some 2 trays over here, and we analyzed our spirit, and we are getting some good quality rectified spirit. So on the other side, those 2 vessels are for called as intermediate receivers for rectified spirit, and that one is for receiving technical alcohol. And this one, the big one, you see, is known as a bulk storage vessel for receiving the spirit we always receive from here in case we don't have customers. And the red tank you see over there is a molasses receiving tank vessel, but as well it could be an underground vessel, so as to reduce on to economize on the space we are seeing over there. Yes. And here we have our loading house, whereby we have our flow meters over there, and for us to have an accurate, so that we don't lose much more spirit to our customers, or we don't cheat our customers. And down there, as you can see, those 2 vessels, one is for spent lease. Sometimes we have losses in spent lease. We try to recycle it back to the plant. Then the other one is a beer wash pump tank, which the beer which has been passed through the degasser flows into that tank, and it is pumped to the analyzer. And here is our spent wash. Basically, why we have this spent wash tank is to further preheat our preheated beer from the top of the beer heaters. In normal cases, beer heaters preheat up to, they have a delta T of 26. That means if you enter your beer from your fermenter at 30 degree or 36 or 33, you'll have your beer entering, you'll have your beer flowing into the analyzer at 56. So for us to have an economical and efficient plant running without stress, we try to preheat, as I showed you from the start, that to preheat that beer so that it can go up to 80 degree, at least 80 or 90 degree into our analyzer tower without any problem. Yeah, we at ECO-Distilleries, we do fabricate, install, and commission distillery plants, from rectified plants to ENA, from RS rectified spirit to ENA plants, easily. Yeah, at a good commissioning costs. And we are located in Uganda. And everything is possible. That's Uganda, Africa. Thank you, my team. And the other side is the starch plant we are putting up. That structure, the wall of it, the way you think, that's where we're having wet and dry process. And wow, that is it. And right now we are running. After commissioning this plant, we are managing it for some month. Then after, we shall hand over to the client. I thank you. My name's Leonard Viemaro from Uganda. Thank you. I've said that we run these plants at ECO-Distilleries Engineering Company. We commission them, we erect them, we fabricate them, and in most cases we train the client's trainees so that when we are handing over a plant, it should be easily run by the local people available in your place. We do fabricate, commission, install, and commission the plants for you at a cheaper cost. We are located in Uganda, that is Africa, and I'm by the names Leonard Viemaro, the Managing Director, ECO-Distillery, and Chief Engineer of the plant. I thank you all. Thank you, team.